injection on the modern car comparison. Well, let's look at the carburetor first. I have a carburetor of a lawnmower here. They still work great, but there's disadvantages to the carburetor. The main things is that with altitude and temperature change, they have to be adjusted normally. With the advent of modern digital circuitry boards, we're able to have what's called the ECU, which is going to be able to use to control all the aspects of the car, which the carburetor only controls the air-fuel mixture. The ECU on most cars is located behind the kick panel down here. And this guy, it's hiding right here. Let's pull it out for you so you can see it. Probably wasn't good. It's located right here. This is going to be your ECU on most of your cars. Most of them are located under the dashboard.
Alright, now I'm going to show you some of the main components of the ECU. Right here is the CPU. It's the brain. It's responsible for making the decisions and outputting signals to the various processes that the ECU controls. These four chips right here are application-specific integrated circuits. They're EEPROM memories, which means they have specific programs built into them. These programs control the air-to-fuel ratio, the ignition timing, the idle speed, and the variable valve control. These things right here are voltage regulators. Right here, these are glass passivated rectifier chips. They convert AC current to DC current. These round things you see all right in here, those are all capacitors. And then of course the little bars you see, those are resistors. Right here are diode, these three chips right here are diode transistor chips. They're logic chips that is based on diode transistor logic. The gating function is performed by the diode network, and the amplifying function is performed by transistors. An EEPROM, or erasable programmable read-only memory, is a type of memory chip that retains its data when the power supply is switched off. It is an array of floating gate transistors individually programmed by an electronic device that supplies higher voltages than those normally used in digital circuits. Once programmed, an EEPROM can be erased by exposing it to a strong ultraviolet light. Flash memory is also used in this device. It's an electronic, non-volatile computer storage medium that can be electrically erased and reprogrammed. In this case, flash memory is used to store the data from the sensors briefly while the CPU reads that, makes a decision, and then the data is erased and new data is stored. The first area that the ECU controls is the air-to-fuel ratio. Using several sensors, the ECU calculates the quality of fuel to inject into the compression chamber. For instance, if an engine is first being cranked and is cold, the fuel mixture will be rich so that the engine will burn hotter and heat itself up quickly. There are three key sensors that are utilized in this process. The first is the throttle sensor, shown here. Just like its name, the sensor determines exactly how high the throttle is set by the user. The second is the mass flow sensor. This determines how much additional air is being sucked into the engine as the throttle is increased and allows the ECU to inject the correct quality for that particular scenario. The final sensor is the engine coolant temperature sensor. This determines how hot or cold the engine is, and from those readings, the ECU adjusts how rich the injection should be.
Now to do all this, the sensors send analog signals to the ECU. And what the ECU has to do, it has to convert it. It uses analog to digital converters to convert the analog sensor into digital. Normally they vary from 0 to 1.5 volts, and this is going to be done here on the circuit board. The second area that the ECU controls is the ignition timing. This means that it adjusts the exact moment when the spark plug fires into the compression chamber to get the optimal balance of power and efficiency from the engine. One of the key things that the ECU makes adjust is for knock. There is a knock sensor, and whenever it is activated, the ECU gradually slows the time of the ignition until the knock goes away. The ECU can even send a signal to an automatic transmission to downshift the speed of the RPM up or down depending upon the knock. And that's going to be located down here, the knock sensor. The ECU also has high-level digital outputs, which is going to be used to fire on the spark plugs when it sends a signal. This high voltage is then sent to the coil packs, which the coil packs send off and fire out the spark plugs.
The next thing that the ECU controls is the idle speed. The ECU monitors the RPM of the engine via a crankshaft position sensor. Using that data, the ECU sends signals to a programmable throttle stop that physically maintains the idle speed.
The final thing the ECU controls is the variable valve timing, actually when the valve opens and closes. The valve determines the flow of intake and exhaust gases entering and exiting the combustion chamber. By adjusting the valve timing, the ECU can improve the car's performance, fuel economy, and emissions. This is the variable valve timing solenoid, which is controlled by the ECU. Digital analog converters are part of the ECU also, because sometimes you need to send an analog output. This is an example of this would be with the speedometer. The signal from the ECU is then sent to the speedometer to tell you what speed you're at.
If everything works in your ECU, then this is what should happen.